Again, thanks for the invitation. Everyone hears me, right?
Yeah.
I think I do hear you from time to time, but if your sound ever goes, just shout or just let me know, and then I'll stop and take questions. So yeah, as I said, I will just spend a couple of minutes just describing the type of problems we work on, and then that should stage the questions, and then we can do a Q&A. As long as people want. Although it's 2 p.m. here, so it's actually work time. So I kind of arranged my meetings to leave a gap, so I have some time free to just chat as well. So basically, the types of problems we think about on a daily basis are centered around, as I said, an object called exoplanets. These are planets outside the solar system. Now, when I say exoplanets, I guess the first thing that comes to your mind is the set of planets that we know and love in our own solar system, the 8 planets. However, the exoplanets, the planets outside the solar system, can actually be wildly different from the ones that we see in our own solar system. And the reason is our sun is a particular star called, so-called in astrophysics lingo, so-called a G-type star, but there are many stars of various different temperatures and brightnesses. And if you just were to populate different exoplanets around these stars, you would get very different equivalent temperatures. That is, the temperature on the surface of these stars, sorry, on these exoplanets would be wildly different from the ones that we see in our own solar system. Although our solar system obviously is not a very simple system, it's got at least 8 planets, and these 8 planets cover a large range of temperatures, as well as radii. Like we've got, let's say, the Jupiter, which is our kind of brother. It's pretty big. It's a gas giant, which means that it's got a really large hydrogen and helium envelope around the core. Towards its core, the hydrogen and basically so much squeeze, so it has so much high pressure that it liquefies. So it's basically the hydrogen is in liquid form towards the center. And we've got the more terrestrial planets like the Earth first of all, and then we've got the Mars, Venus, Mercury. These are solid planets, and again, there's a range of temperatures on them. But as you get the idea, there's a large variation in the conditions, possible conditions on these exoplanets. One thing I have not even mentioned yet is the existence of potential atmospheres, which complicates the whole picture even further, because when you have atmospheres, there can be greenhouse effects on these exoplanets, and then the temperature range can even be more different than what you would normally assume. Okay, so that's basically what an exoplanet is and how it basically should appear in your imagination. Now, one question you'll ask is, how do you actually observe these? Because this has to be a science, it has to be observation based. What is the evidence that, first of all, that they exist? Second, even if we do detect them, how do we further characterize them? Well, in order to detect it, unfortunately, if you were to take a random telescope and just point it at a particular star, it is extremely unlikely for you to be able to angularly resolve that planet just next to its star, because stars are usually orders of magnitude brighter than their hosts. Than their orbiting planets, because they generate their own energy, their own photons. They're very bright. Whereas planets usually just reflect light, and even if they don't reflect, they have some thermal radiation as well, but that's very little. So you don't actually, most of the time, you don't hope to observe that light, except when you are far in the infrared region, where the planet may actually be bright enough for you to directly observe it. But my point is, it is extremely hard to do this in general, and it is very rare that one can actually directly observe an exoplanet around its host star. So most of the time, instead of just trying to resolve light, what people do is they look for so-called indirect effects. When the planet exists and orbits around its own star, its host star, there are certain physical observables that we can use to indirectly infer the existence of an exoplanet around the particular star. There are two such main methods. One is called the transit method. That is when an exoplanet passes in front of your line of sight between you and the star. And that basically results in a temporary dimming of the star. So the brightness, the flux from the star decreases temporarily. And this happens at a particular period. So with certain time intervals. Now, if you were to watch this star over a long time, then you would eventually conclude that there is an object passing in front of its host star with certain periodicity, and you can then further characterize that. The other method, as I said, there are two methods. The other method is called the radial velocity method, and that's the idea that when you have a change in the relative velocity between an observer and an emitter of light, I mean, then the color of that light observed by the observer slightly changes. In physics, we call this the Doppler effect, and you can use this effect along with the idea that a star and a planet basically orbit around a common center of mass. You can use these two facts to eventually figure out that the star is essentially being shaken, so-called, by the planet. That shaking happens because, I mean, you may initially thought that the planet actually just orbits around the host star. That is 99% true, but it's not exactly true because they actually orbit about a common center of mass. That means the star itself is in motion with respect to that common center of mass, which further means that you will see color shifts due to the existence of that planet in the stellar light. So if you carefully observe the energies of those photons coming from the host star, then you can infer the existence of a planet around it, especially if the orbital inclination is favorable. Obviously, there are cases in which that is not the case, and this also holds true for the previous method that I mentioned, the transit method. Because in the transit method, the exoplanet has to cross between your line of sight, and the star. So that is also a very unlikely situation. But because there are billions and billions of exoplanets, well, at least in our galaxy, we know that there has to be hundreds of billions of these, then statistically speaking, you get to observe many thousands of those transiting. So far, the total number of exoplanets known and confirmed is about 4,010, and that number is increasing rapidly. There is a new experiment called the Transiting Exoplanet Survey Satellite, which was launched into space very recently in April last year, not this year. And TESS basically keeps on, well, along with many other experiments, not just TESS, but TESS also is designed to to find such exoplanets by the transit method. As a result of all these efforts, the number is increasing. And with that, I think this is a kind of a low-level introduction to the whole idea of exoplanets and the world of exoplanets. I'll just cut it short here, and let's just proceed with questions and answers.
Yeah, thank you for the introduction.
You're welcome. So, any questions? I didn't hear anything. Sorry if someone spoke.
Can you hear us, Anna? Can you?
Yes, now I do.
Okay, maybe you can come close. Okay, so I don't know if this is going to be a funny question, but forgive me if it is a funny question for you.
No.
So there's actually thousands of more planets than the ones that the 8 planets that we actually know about, or that I know about.
That is true.
Like that, like 4,000 plus.
Yeah, 4,000 plus.
Wow.
And the actual number, the underlying number has to be billions.
Billions.
In our galaxy, yeah.
Wow. I got stuck there. That's why I needed to reconfirm that. I'm sorry.
Yeah, I mean, obviously, one thing just to clarify is we infer this number, we don't observe them individually, we only know confirm existence of about 4,000 of them, and this number billion we get basically by just extrapolating the frequency with which we observe them. However, even just considering these 4,000s, as I said, we only indirectly observe many of them. We most likely, I mean, if you just pick a random exoplanet, it is unlikely that you'll actually be able to see a picture of it, a photograph of it. Most of them we know through indirect methods.
But these are proven methods, right?
Yes, yes.
They do exist.
Yes, they do exist.
How come they don't put them in the solar system with the other 8 planets that we see all the time?
Well, the 8 planets that we see, well, first of all, I guess it's partly also, I mean, it's a great question that you ask this. Why don't we advertise these in the textbooks as much as we do the 8 planets that we know? I guess it's partly historic because exoplanet science is very, very new. It's been out there only for about 30 years. And
30.
yeah, 30. So it's pretty young, I would say. And I'm sure in the decades to come, we will be teaching the high schoolers especially some of the most important exoplanets names and probably characteristics as well. I think they'll eventually enter the textbooks. Yeah.
So can you give us like some of their names and the characteristics so we can get the knowledge in advance? Yeah, do they have names?
Yeah, they do have names, but these names are usually not very interesting. They usually
4, 1, 6, 8, 3.
yeah. So the names are just the discoverer telescope's name and a number that follows that, and then finally a letter. That letter identifies which order around the star the particular planet is. So it's not a very interesting name for most of them.
Yeah. Thank you so much.
Sure.
Yeah, you can go.
Okay. One sec. So, hi, I'm Perica from Croatia. And one question for you as astrophysicist. Sorry. So probably you heard about that mysterious 9th planet that it's like coming and going from our solar system. So what's like your opinion about that mysterious planet? I think the name starts with N or something.
Yeah. Well, it is likely that there may exist such well, I shouldn't say as such a planet. Well, when I say 9th planet, I obviously don't refer to Pluto. But yes, it is likely that such a planet exists. It has not been independently shown that it exists because we just need more data. So it is not a settled situation. Yes, there is some mild evidence that there is a new and 9th planet in the solar system.
Okay, yeah, thank you.
Yep. Hi, so
I'm Chiago from Nigeria. So two questions. First of all, these planets that you talk about, can you confirm whether there are living things there? And if yes, what kind of living things?
Well, first, it's really hard to confirm, to make that confirmation. For most of them, we only know their radius and mass, maybe. So that sometimes gives you the density from which you can start inferring very roughly their internal composition, whether they are mostly made of water or silicon or, I don't know, carbon, or maybe iron. So very roughly, but as for the atmospheres, it's really, really hard because the atmosphere is very thin. So it's either radiates or absorbs very little photons. So it's really hard. So you have to observe the system for long amounts of time. And even then, it's really hard. There are many systematic sources of uncertainty. So yes, I would say it is really hard and currently not is a task that has not been established.
Okay. Okay, the second question is, the whole thing sounds so interesting to me. So I'm curious to know whether in the work that you do you believe or try to search whether there's an existence of a God? Or do you think this whole thing is just something that came up, developed, and here we are? I mean, what is there to it? How did it all come into existence? Is it part of the work that you do, or even personally, what do you think from your research?
Well, I mean, I guess this is a really personal question because the scientific method is certainly, I mean, its task is certainly not to find a God or a meaning. It basically looks for correlations and causations and tries to establish physical mechanisms that underlie those correlations. What you interpret out of that, I think it's all a personal thing. Many people interpret it as so-called meaning of life. Many other people personalize that meaning to various other forms. So I guess what I would very generally say is, as long as that meaning that you attach to the output of the scientific methods, as long as that does not interfere with the observations, I think any interpretation is totally reasonable. Just one note: the problem, there's a further problem, which is that in the scientific method, there's a notion called Bayesianism. It is the idea that, well, okay, it's a subset of Bayesianism, but the idea is that you have to make as few assumptions as possible. It's called the parsimony prior or Occam's razors in various other contexts. So you have to make it as few assumptions as possible. So I guess the fewest assumption that you can make is that there is no meaning other than the processes that we observe. But I think it is a personal choice to attach a meaning to anything, and that is certainly not against the scientific methods, unless, as I said, unless your assumptions and various meanings that you attach start interfering with the physical reality.
Okay, thank you.
Okay. There's a question coming.
Okay, I hope it's not as hard as this one.
Hello.
Hello.
Realistically speaking, what are the chances we got to send anything to an exoplanet to observe it from a closer perspective anytime soon?
Sorry, descend onto an exoplanet?
To send something to observe, yeah, because right now we are observing exoplanets in a indirect manner. And what are the chances we have, like technologically speaking, to send something back to observe it more closely.
Yeah, so I guess in the next 40 to 50 years, there is a small chance. There's a program called Breakthrough Starshot, and through that, it may be possible to send nanorobots to the closest such star systems. And if there are exoplanets orbiting them, well, if there are interesting exoplanet candidates around them, then we may actually be able to take pictures of them. But I guess it all depends on what you mean by, like, if you really mean like sending humans or even like a macroscopic robot, I think. Sorry, I couldn't hear you, but I guess.
Yeah.
Again, sorry, so you got totally broken.
Sorry. Do you hear me now?
Yes, now I do.
I was talking about sending some probe or some technological device. I was not talking about sending humans.
Yeah, so humans are really hard, and macroscopic robots are also very hard. I think the only possibility would be to send like nanorobots, things that have really, really small mass. Because you need to be able to travel very close to the speed of light, which would only be possible if your mass is about nanogram or so. Or even, yeah.
Another question.
Thanks.
Okay, so maybe I can ask, what is the importance of these planets for NASA or your studies? Why we are studying on it? Maybe I mean, what's the reason of this?
Well, I think there are two folds to this question. First, we need to understand, or we want to understand, the origin of our solar system. And in order to answer many questions relevant to the origin of our own solar system, we need to understand similar systems to draw statistical conclusions. So that's one reason we want to understand our own origins. The second one, which is usually more well known, but unfortunately not a very scientific one, is the fact that we want to see if there is a twin Earth. We want to understand if there is an Earth-like exoplanet out there, or exoplanets out there that are very close to the Earth in terms of many characteristics. If we ever find one, then this may also be a laboratory for us to understand like the initial conditions of life. So yeah, it's got two folds, I'd say. The first one is easier to sell in an astrophysical context. The second one, I think, has more astrobiological implications.
Yeah. Sorry, I'm gonna jump in. So first, we want to understand the solar system better, and second thing is to see if we can find another planet that has similar characteristics as the Earth. Is that right? Do I understand it right?
Well, yeah, if you can.
Okay. I'll have to think about my question. Give me a minute. Somebody else can jump in.
My question is instead of the red star we have like sun, and if it would be a blue star, what would be happen? It like we could be alive still, or more big radiation, and it wouldn't be possible the Earth exists.
So if it was a blue star like OB stars, I think it would be pretty hard to establish life. Obviously, we just don't know to some extent, but what I actually mean is if you were to replace the current sun with a pretty blue star, then it would pretty much erase the light, the life out of Earth. pretty quickly, because there would be just too much UV radiation from a blue star. And obviously the sun also produces a lot of UV radiation, but we have an atmosphere that has adapted to this level of UV radiation. If you were to replace the sun with a much higher UV radiating star, then this is not a reproducible situation, but the guesses are that it's probably going to just erase life. However, it's in like we just cannot simulate these things to arbitrary details. So it may even be possible that if you're farther away from these very blue stars, life may still be possible.
There is possibility other blue star orbit planet than alive.
Yes. True.
And another question I have, I am really curious about inside the black hole. There is huge gravity, as I know, and it's like mass is going away, so they are like gluing each other. I don't have so much information about that. Can you make it clear? If I know you know better, so I want this more clear inside this black hole gravity thing.
Okay. So
I hope you understood it.
I'm not sure I understand the question. I understand the topic, if that helps.
Yes.
So, like, first of all, I guess one thing I should clarify is when you say inside the black hole.
Yes, there's something already fall down there. What happens later? Yes.
We actually don't know. The simplest answer.
Okay, about the theory.
Yes. Well, so when there is so much uncertainty in the theory, you just don't know unless you have data, and we don't have data from inside the black hole. The inside of a black hole, and when I say that, I really mean the inside of an event horizon, because people just imagine that there's like this thing who's in, like, okay, there's a black hole, but it's basically just the surface and there is no material there. And once you pass a particular radius around the black hole, you cannot come back. That is also true. And when you approach the black hole, the time basically ticks slower for you, for the observer that is very close to the black hole. These are things we know from gravitation, from our theory of gravitation, the general theory of relativity. But there is also a lot of speculation about what would happen to you if you fall into a black hole, because inside the black hole we don't get any information from. And well, there is some radiation called Hawking radiation, which complicates the whole story, but I won't go really into much detail about that. What you would probably be interested in hearing is, if you were to fall into black hole, what would happen to you? Well, you would probably just get elongated like a spaghetti. And the reason is there is so much tidal forces around a black hole. That would be that's what would happen to you. And time would fly slower and slower for you. And that's all we know.
Thank you so much.
You're welcome.
Another question is coming. You can think about your question. Okay, good.
Hi again. So the name of this topic is the life on other planets. So I want to know, like, your personal opinion from your so far scientific knowledge. What is the chances that there is life on other planets?
That's the million-dollar question. I don't think I have the answer to this.
But from your knowledge so far, let's say, what are the chances? Like, you can stay in a percentage, promils, whatever, just like your personal opinion. Is there any chance for that or not?
Okay, so here's the thing. This question of how many life forms are there trying to communicate with us in our galaxy this question can be broken into two parts. One of which can be addressed using observations. The other part cannot. The part that we observe is that roughly there's one exoplanet out there that is in orbit around the sun, sun-like star. Now that we know as an observational evidence. But apart from that, extrapolating that to the number of such life forms, that is the tricky part. And we have pretty wide uniform priors on these probabilities. You have to think about what fraction of such exoplanets actually produce life forms, then what fraction of those produce technology, and what fraction of those actually do communicate. And in between, you have to also calculate what fraction of them produces intelligent life, as opposed to just dumb life.
Mechanical.
Yeah, so all of these have uncertain priors, and by just changing your priors, you can actually get numbers that are certainly much larger than unity, which means that by now someone should have contacted us already if these calculations are correct. And since no one has ever done that, there is a discrepancy that is called the Fermi Paradox, and we don't exactly know why. It is one of the options, one of the possibilities, is that because whatever life forms that come into existence, because they kill each other or kill themselves maybe over some certain time scale, then if let's say if that time scale is short enough, then it may just be possible that we don't see life forms out there just because they don't live long enough. And we, at the same time, we won't be living long enough to observe enough of them. That is a very pessimistic solution to the Fermi paradox.
Okay, but like from another hand, don't you think that maybe, like, let's put it like this, that they tried to contact us, but we are not intelligent enough so far that we can decipher that message or something?
Well, this is a way of sweeping things under the rug, I would say, because so far we know that there are four fundamental forces in nature, and even if we do discover a fifth force or further forces, I don't think, well, okay, it's really hard to say I don't think, but it's not very likely that they can be used for intergalactic or interstellar communication. There are certain interactions that we are yet to discover, but we think that these are short ranged interactions. So may or may not be useful to extraterrestrial intelligence to communicate with us without us not noticing.
Okay, thank you.
Okay, I have a question. So what kind of elements or properties we are observing to find a life in other planets? Like what are you observing? What kind of elements are very critical?
We certainly look for so-called biomarkers, things that only non-equilibrium chemistry, that is life, can produce and maintain. And there are many such molecules, and many of which I even don't know. There are certain people who think about this on a daily basis. But certainly things that we start, basically, we have one good example of such a case, which is our own Earth. So people just take the Earth's atmosphere and try to find the relevant features in the Earth's atmosphere elsewhere. That is the very first thing one could try, but obviously this narrows down to search unrealistically, because we kind of start with the assumption that the life out there must be similar to that on Earth, which is a very crude assumption, may not be true.
Tansu, hi.
Oh, selam.
Selam. I had some problems with flight, and now, yeah, First of all, thank you so much for your time.
You're welcome.
Yeah, so just to speed up things in a more cosmological perspective, there are a bunch of people here. I want to continue from this Fermi paradox. So it seems like we are extremely rare, or in general, intelligent life seems to be rare with the current data we have. So it seems like it's very rare. And I want to point out this fine-tuning problem. Like the universe, it seems like the gravitational constant, speed of light, if they were a little bit different, then the universe wouldn't be in the same way as it's today. So it seems like the universe is trying to make us by making these constants in this way. And as for now, we know that intelligent life is very rare. So what do you think about this from this perspective, from cosmological perspective, these fundamental constants are so tuned that it enables our universe the way it is?
So this anthropic principle that you mentioned is, we could just spend evenings and nights and ages just talking about this. Unfortunately, I would say there's no true answer to this debate. So some people, I'll just give both views and just call it a day. Some people just argue that the anthropic principle essentially is a waste of time, just because you find basically something that you cannot explain, and then you draw a line and say, okay, this is the end of my reasoning. Whatever is beyond this, I will just try to explain using the anthropic principle, which may, to some people, which sounds like it is the end of the scientific methods, and some people just go as aggressive as just calling this like a religion itself. Now, on the other hand, there are good arguments to say that if the parameters of the universe, which we precisely measure, were slightly different, we wouldn't be here. So the fact that we observe this kind of explains the parameters themselves, because it is a natural value for them to get. If we were to observe values in which the universe wouldn't be stable, we wouldn't be observing them because the universe wouldn't be stable. So it is kind of a logical statement to say this. However, it kind of also bypasses further investigation and further scientific interrogation into the topic. So I think it's really hard to say which one is correct. I think kind of an agnostic point of view would be to say that the anthropic principle is our current possible best approximation of what the reality is, and this shouldn't stop ourselves from looking for further explanations. And once we find it, we'll just abolish the anthropic principle and call it our greatest blunder of all time. But until that day, we will probably we will have to be happy with the anthropic principle.
Yeah.
Okay. There is one more question.
Hi again.
Hey.
So I just remember something that I read recently, that like now there is like a group of scientists that they are trying kind of to create, let's call it a path, or to open like a way towards the multiverses. So like, what's your opinion about that? Is there like, I mean, now when we are talking about exoplanets, it's like you're saying that it's like, I mean, it's nothing visible like with the naked eye and everything. And is there any chance that there is like outside of our, let's call it solar system, maybe a path towards the multiverses, and maybe that I'm now referring to that first question that I asked you, that this mysterious Planet 9 is coming from there somehow.
Okay. So there's a bunch of problems which got mixed into each other here. I mean, I first of all, I don't think the Planet 9 and the exoplanets have anything to do with the multiverse, because they're really, really different problems. I mean, I would almost argue that they have no relation to each other, almost. So I've never heard people actually try to create wormholes or something like that you mentioned, or alternate. I kind of masked the first part of your message, but to the best of my knowledge, I don't actually know anyone who is actively trying to do this, and I don't even know if it is even possible to create such alternative universes.
Okay, so in your personal opinion, there is no chance that kind of other universes exist except ours.
No. So this multiverse thing actually is just an interpretation of quantum mechanics, and it is totally valid. It's just an interpretation. That is to say, you cannot really tell apart different interpretations of quantum mechanics just based on observation. It is an interpretation, and it may just be that at every time we just throw the dices, and these random decisions just send us into different and independent universes. Possible. Can I show using data that this is the case? No.
Yeah. Okay, thank you.
Is there any question? There is a question. Hey, welcome.
Hello.
Hey.
Hello.
Hi.
Do we have a chance to live in planets that don't have that have atmosphere?
Sorry, could you repeat that?
Do we have a chance to live in planets that have an atmosphere?
Don't have.
Have.
Yeah. Okay. Yeah, we could certainly do that. I mean, Mars is an example. Mars does have an atmosphere, but it's much thinner than the atmosphere that we are used on Earth. So you could treat it, as a planet without the atmosphere, or a very, very thin atmosphere. And it is certainly possible, because you could just have people wear spacesuits all the time when they leave the wherever their buildings are, and you can also produce agricultural products in certain areas using just stellar light and certain ingredients like carbon dioxide, etc., and water. So basically it's possible. It has not been done yet, but there are certain and very serious plans to do that, especially for Mars, but also sometimes including Moon itself. And in the future, certainly many other planets as well. But for the moment, I think the best bet would be Mars. And I think you're young enough probably to see that actually happen.
But in Mars, there is wind or no?
There are certain winds. It's not as strong as those on Earth because the atmosphere is very thin. But yes, there are winds.
Very good. Thank you.
So, is there any other question before closing?
If we're closing, I have one last one.
Okay, there is one last one.
Okay. Let's get
and again, I apologize.
She finally thought about it.
No. I thought about it, but I thought about whether I should ask it or not ask it because my questions are funny and stupid sometimes.
No, please.
My last question is, imagine we found another planet that has the same or similar characteristics as the Earth. What do we do? Do we start marketing life on another planet? What are we going to do?
Well,
Is it, I mean, I'm sorry, I'm a business person, so I'm thinking like the first thing that comes to my mind is, what do we do? Do we start marketing a life on another planet and start selling tickets to X12379L? I mean, imagine, hypothetically speaking, apparently we don't know if this is even possible. Let's just imagine.
I'm sure people will think about marketing as well. The very first thing that comes to my mind is actually even more fundamental than that, which is the very question of whether we should send a signal there or not. Because that is the very first question probably all humanity would have to agree on before sending a signal if we ever find an exoplanet that has exactly the same characteristics as the Earth. Because that's a very dangerous thing to do, to send a signal. Because if you send a signal, imagine it's 50 light years away. About 100 years later, you just don't know what you're going to get back. Are you going to get back a friendly message? Are you going to get back like an intergalactic army? You don't just know. And it is, I mean, people, first of all, would have to probably do a poll or something, like everyone would have to agree on the decision, and eventually we would probably just be sending a signal. If people say it's okay, then once that happens, I guess we would try to characterize it even further. That's a boring thing. I know marketing is more fun. So yeah, you could certainly market stuff as well.
No, because we have other scientists out there who keep telling us that there's, the end of the world is coming and all the stars will die and Earth there is an end to Earth and everything. So I'm sure we have a lot of other smart human species in the world that on the Earth that we live in who are gonna, try to find a ticket way out here.
I'm sure people
that was the point of my question, but it's like I said, it's
but the issue is like actually finding an exoplanet that has the right characteristic doesn't necessarily mean that you can actually send people there, because you have to establish the characteristics to a great precision before people will be willing to purchase a ticket to a place. Because, I mean, would you be traveling to a place that you don't even know what exists there?
Oh, but we have people doing a lot of stupid things, not knowing what's on the other end of the, tunnel either too, but, anyway.
Well, if you can find such people and at the same time such rich and such people, then yeah, you could, I guess, do that. And you could certainly raise a lot of money from that.
No, I'm not interested. But thanks.
Okay, a personal question. How did you decide to work on this topic? How did it happen? Like, has it always in your mind and you just realized that it's like hot topic in the science and then you just turn into this topic?
So actually, I've only been working on exoplanet for about a year and a month. So before that, well, I mean, per se. Before that, I was working on dark matter, which is again a different topic in cosmology, but not necessarily exoplanets. These are all coupled problems. I mean, there is a single universe and you continue to think about it at different scales. So yeah, I guess exoplanets, it's just that I kind of wanted to shift my interest slightly because I wanted to explore other problems in astrophysics. And that's what I'm doing at the moment.
Can you just summarize dark matter in 3 sentences for the audience here?
So dark matter is a type of matter in the universe that is transparent, gas-like, and about makes up about 26% of the universe. So it is like an invisible substance, more like a gas that you cannot touch. If, for example, the Earth was made of dark matter, you'd just be flying through it.
Okay. Tansu, thank you so much for your time. We really do.
Sure. I really enjoyed this. Thank you very much for coming.
And have a nice day in your office and in your
Yeah, thank you very much. Yeah, this was very fun.
Okay, do you want to say something?
Yeah.
Okay. There is a last goodbye from Umut.
Okay.
Yeah. Tansu, thank you so much.
Yeah, thanks for the invitation. I really enjoyed this.
Let's keep in touch again. And thank you. I think
Sure.
everybody.
Yeah. Thank you so much. Have a nice day.
And I wish you all the good luck.
Have a nice evening. Bye. Take care.